Hello everyone, good morning. Um, like my introduction, so my name is Santosh. I lead engineering at Couchbase Bangalore. Today I'll be talking about how you can enhance your GenAI applications using something called hybrid search, right? GenAI applications are a commonplace everywhere now, but typically they've been using something called vector search. How many of you are familiar with vector search? Okay, that's a good number. So today I'm going to talk about how you can enhance your application beyond just vector search and how you can do it in topologies which are much more advanced than just doing it on the cloud. Let's get started. Before we delve into how you can enhance GenAI application using hybrid search, I'd like to talk about key concepts in search so that we are all on the same page. Once we do that, let's understand what is hybrid search, right? After that, let's look at what are the various search topologies that are available and how you can do hybrid search across each of these topologies. And finally, let's look at a few examples of how you can enhance a GenAI application using hybrid search. So let's start with the basics. The most fundamental form of search, right, which has existed for maybe 4 decades now, is exact and range search, right? Most of our grandfathers' databases also had this. And let's take an example to make this very clear for everybody. I've just taken a screenshot from one of the popular e-commerce sites in India, where let's say you go look for a shirt or a different kind of any sort of clothing item, right? You'll typically get a search bar on the left which talks about what type of or what properties you can select for the item you're buying on the e-commerce site, right? Now let's say you pick a particular brand, right? And you select the price range. Typically what happens in the backend, this is an exact and a range search, right? A search where you match the product combination you've selected and the price range you've selected. And a search like this is powered by something called secondary indexing, which you probably would have studied in your computer science classes, right? The search is on a very large space. The goal is to constrain the space into a smaller set of result items. In a search like this, the most important factor is performance, right? So when you search for a product like this, the search result should come back in an instant. And the goal is always to get an exact match or a range match, right? You are not looking for approximate matches. So this is the concept of exact and range search. I'll move quickly from here because most of you know about this. Let's look at a few examples, right? Product category, price less than, right? Like, all these are examples of exact or range search. I'll move on from this because most of you know about this. Let's look at something more complex, which is text search, right? Instead of selecting the brand, if you type the brand name in your search, right, that translates into text search. The reason it is a text search because you could do possibly things like fuzzy matches. Somebody could do a spelling mistake, right? I'm selecting for Tommy where I do triple M double Y, right? Or I could do single M and double Y. Now, you still want to identify the right product for that, right? So searches like this are handled by text searches, which let you match phrases. It need not be a single word. It could be a phrase. It could be wildcards. It could be fuzzy as well, in the sense that even if the search is not exact, it varies in some form, you can still find the object. It is important to know the type of index that is used for text search, right? Your secondary indexes that you build on databases don't work for text search. Text search is through something called inverted index. And one other concept that is very important for text search is result boosting. Result boosting is something like enhancing the search on certain attributes, right? For example, you have Bangalore in the name of the city, you have Bangalore in the description. You want to boost the search if you find it in the description, right? So such capabilities are there in text search, which are not there in secondary search. So anything to do with user-entered content that needs to be searched usually falls under text search. Now let's look at few examples. So if you want to do a match phrase search, right, you could search for this phrase in all your document content. If you want to do a wildcard search like data star, you could continue to do that as well. If you want to do a fuzzy search, like let's say I want to search for analytics, but you see there I've done a spelling mistake and I've given a fuzziness of 2, right? So the search would still find this. And finally, when I talk about boosting, let's say I have a field city and I'm trying to match for Bangalore, which I'm boosting by 5, or I could do a field description and I'm matching by Bangalore, right? So the searches for field city is given a higher ranking, right? Now let's look at semantic or vector search. So semantic or vector search is essentially searching based on understanding behind the meaning of the query, right? It is not comparing the content of the text, or it is not trying to do a range, but it is trying to find items which have similar meaning. And how do you define meaning? How many of you are aware of the concept of embedding here? Okay, quite a few. So embedding is essentially translating any entity into a mathematical representation in simple words, right? So you take a content, you give it to an embedding model, the embedding model gives you back a mathematical representation of it. And then you can do various operations like search on that mathematical representation, right? And in contextual search, precision and recall are very important. So when you do a search, in an exact search, so if you're searching for name is Santosh, yeah, you just want to find that, right? Or if you want to find a particular price range, you just want to find that. But in a semantic search, it is more nuanced in the sense that you want to get results which are nearer to the concept you are searching for, but you also want to see how good the results are, right? And what is the volume of the results? The quality of the result is measured by precision. The volume of the result is measured by recall in some sense. I won't delve too much into precision and recall because it's a concept in itself. It will take some time. And the type of indexes that you use for vector search are very, very different than what you use for secondary search or text search, right? Now let's take an example here, which is again from your e-commerce, right? Let's go pick up, let's say somebody was looking for a blue color t-shirt, right? A blue color t-shirt is fine, but you could semantically match or contextually match blue to turquoise and cyan as well, right? A turquoise or a cyan t-shirt is very similar to blue too. So you would want to return items which are tagged as cyan or turquoise as well. And if you try to do a text search or if you try to do a secondary search, you would never get something like cyan or turquoise because there is no text match, there is no direct match, right? It is a semantic match. It is logically equivalent, right? And a search like this needs vector search. And let's look at some examples. How do you do vector search, right? Let's say you have a field of product embedding. So I talked about embeddings, right? So let's say in the previous example, you would embed the colors, right? So you would get a 3-dimensional embedding for colors like this, right? And you could try to find another color which is close to that in the embedding space, right? And with k is equal to 3, I'm saying find 3 nearest colors to this given color, right? So you can use concepts like this to constrain the search space based on semantic meaning. Now that we understand what is exact search, what is range search, and what is semantic search, let's look at what is hybrid search. Hybrid search is exact, text, and semantic in a single query and a single system. Why do I emphasize single query and single system? You would all be thinking that, hey, this guy didn't talk anything new now, right? Our text search, our range search, exact search, vector search all existed. And we all do it today, right? So what I showed on an e-commerce example happens today, right? But it happens on multiple systems. Your e-commerce product catalog is typically on some sort of a database, right? Commonly a NoSQL database or a relational database. You have your text search on a text search engine, right, where you move that data to usually do a text search. You have your data moved into some other form of vector search engine, like in case of open source as FAS, there are many proprietary technologies as well, to find the semantic meaning, right? So the data is getting into multiple systems to achieve this use case. But what I'm talking about in hybrid search is bringing all of that together into a single system and a single query. Real world applications are hybrid, right? Very rarely they are vector only. In many cases, they could be range or text only, right? But it is very rare they are vector only. A single query, a single system simplify a lot of things for doing hybrid search, right? You essentially keep your data in one place. You avoid data sprawl. Simplifies data governance. You don't have to govern multiple copies of the data. Simplifies app development, right? In today's world, a search like this is typically done by the application across multiple systems and stitched back together. When you do hybrid search, that is not needed. Let's take a more concrete example to show this. Now, I combined the screenshot which I shared previously into one entity, right? So if you look at this, if you go to any e-commerce website, you will find an example like this, right? Now, let's look at what is happening here. The first search, what you have, where you have users entering the item they're searching for, is actually a text search. The users, when they pick items using checkboxes, typically it's an exact search. When users are sliding the price range, it is a range search. When users are picking the color of the t-shirt they need, it's a vector search. And finally, when they're looking for something like discount, it's a range search because 10 and above, it's a range, right? So as you see, the full use case is actually not any of these individual searches. It's a combination. It's a hybrid search, right? Now, what are the challenges with hybrid search? Why people are not doing it that commonly today, right? Indexing technology needed for each type of search is very, very different. Let's look at what you need for secondary indexing. All of you would have studied this back in college, right? This is how our traditional indexing look like, where you have indexes, items, pointers to them. But your text search index looks something like this, actually. I simplified it for the discussion, but it looks something like this, where you have your search items and the content where it is present, right? Very, very different. Now, how does your vector index look like? Vector index looks like basically you have partitions and you have objects in those partitions, because typically vector search is based on some form of nearest neighbor search, right? So the indexing is very different. To achieve hybrid search, what you need is a technology which can have all three types of indexes within the same system and have the capability to run queries on those indexes on a single query, right? So that's essentially what you need for hybrid search, and given these are so varied, it has been not a common thing in the market. Now let's look at, if you had to use Couchbase and do hybrid search, how would it look like? Just to make it real, right? Now, for the same use case, now I'm creating a text index for the brand, right? I'm saying on the brand field, build a text index. And analyzer standard is, let's leave it for now, just to not digress from the discussion. The second one is, if you want to create an index on the checkbox field for brand, you could create something like a secondary index on the product catalog, right? Next, you could look at a range index, which is again a secondary index on the product catalog. You could do a vector index on the color field with a L2 norm, which is, think of it as a Euclidean distance search with a three-dimensional color vector, right? RGB. And finally, you could do a range search on discount range with a discount index, again a secondary index. So using these 5 indexes on a single system you could essentially solve the whole use case, right? You could run a query which would constrain and return products which matched all their criteria without moving some of the data to a separate text search engine, without moving some of the data to a separate vector search engine, where you have to then stitch that result back in the application. Now let's look at search topologies, right? So we looked at what are the different types of search and how hybrid search combines different types of search. Now, while doing hybrid search, historically, hybrid search has been done by stitching multiple searches together, but it has also been done mostly on the cloud, right? Because most of the products which are in the market which let you do a search like this are cloud offerings. But with modern technologies, we can do a search like this in more complicated architecture. Let me describe one architecture like that. Let us say you want to do a search, which is a hybrid search, at the edge. Let's take an example before we delve into this, right? Let us say you have a utility company which provides devices to their field workers, and the field workers have the manual for the work they do loaded on the device, right? To make it more concrete, let us say the field workers are related to electric utility companies, right? And they go work in areas where there may or may not be network. For example, let's say there is a disaster, there is a hurricane in some area, right? Typically, your internet communications are down. So now a utility worker is there trying to fix something using the manual, right? Historically, the manuals were not very advanced, and people had a struggle trying to search through the manual, and they would do text search only. Now with modern architectures, you could combine regular search, what I showed, the exact search, the text search, and the vector search on the device. For example, in the electric utility industry, a cable, a wire, a line, all of these mean the same thing, right? Now, when a utility worker searches for how do I fix something on a cable, you want to semantically search for line. You want to search for wire, all of that, right? They wouldn't be possible with a text search or an exact search. So you need a semantic search for that. But to constrain the search space, right? The manuals could have multiple topics. The manuals could have multiple headings, right? Now you want to constrain based on they are doing some repair related to an electric line, right? You further want to constrain that with text search and exact search before you apply a semantic search, right? Now all that is possible at the edge with an architecture like this. So let's look at the most fundamental thing in this architecture, which is an embedding model, right? An embedding model is, like I said earlier, converts your content into a mathematical semantic representation called embeddings, right? In more recent times, embedding models, just like LLMs, have been becoming smaller and smaller with quantization, right? Quantization is a technique where you can compress the models. So there are smaller embedding models in the market now, which can be loaded onto mobile devices, right? And Couchbase has an offering called Couchbase Lite, which is a lightweight database which can be run on the mobile device. Combining both of these, right, you could do a hybrid search on the device, right? So when a request comes in, as you see on the search query, right, the application which is running on the device could send the request to the database, do a text search, do a vector search, do an exact search on the device, and return the data back without any connectivity to the external world. That is possible today. Now let's look at the traditional architecture, right? In this traditional architecture, you have an application which is running, it could be running anywhere, but your database is running on the cloud or on-premise, right? In this architecture, you have to send the request to the database and get the result back. But in places where network connectivity is weak or there is no network connectivity, the search request and the response cannot go through, right? Now we're solving that problem by moving the search itself back into the application within the device. Let's take another example, right? How can hybrid search improve customer support, right? If you look at customer support, it's probably one of the places where GenAI is being used very, very commonly, right? The first use case people go for is, how do I simplify my customer support? Either it's a chatbot, root cause analysis, anything else, right? Again, even a customer support use case is not only a vector search use case, right? You can enhance it significantly by doing a hybrid search. Let's take a look at some of the context, right? Let's say you're searching for ticket search, right? You want to find similar semantically meaning tickets, right? Which is a vector search. But you just don't want to do that. Of course, you want to constrain the tickets by product category, when it was created, who's the customer. You want to constrain by keywords and things like that, right? Otherwise, doing a semantic search on your entire ticket corpus is non-viable. Similarly, if you're searching through knowledge bases, right, which is again a common thing for customer support, vector search helps you find semantically similar concept to when you're compared to the topic you're searching for, but you can combine that with phrase search with boosting. Right? If you're searching for something in the knowledge base where there are multiple topics, and if a word arrives in a particular topic, you want to boost that. Right? That is possible with text search, but that's not possible with vector search. Similarly, again, you want to, of course, condense the results using product category or relevance ranks. Let's look at RCA, right? RCA is again one of the common things that is being done in customer support, where we are trying to find the root cause using AI. Right? Semantically similar log messages can be found using vector search, but we also want to again constrain the search space and not search through the entire logs. Right? We want to find the logs based on log messages based on severity, based on when they were created, based on which system. Look for errors, keywords again. So, like I showed the e-commerce example earlier, right? Where hybrid search is definitely a very useful pattern. So similarly, in customer support as well, hybrid search can really, I would say, enhance the experience than just limiting it to vector search. And the story continues for every aspect of GenAI. Like you could look at multiple areas, right? You could look at fraud detection. You could look at any other area in GenAI. Hybrid search, I would say, is very fundamental. In some sense, it is happening today, but I think the key challenge for adoption of hybrid search is the desperate set of technologies that are needed, which make it very difficult. So finally, a recap. So we have different types of search types, we have different topologies, right? Combining them, right, mixing and matching them is essentially what is going to allow users to build, I would say, more sophisticated GenAI applications than what are being built today.